Looking at section C of chapter 7, we're going to talk for a minute about the complements of sets. So we've looked so far at a basic understanding of set notation. We looked at specific sets, including natural numbers, integers, positive and negative, rational numbers, real numbers, both positive and negative. We also talked about finite and infinite sets. We looked at subsets, union and intersection, and set builder notation. So now let's talk about the complements of sets. Well, first thing you need to understand is that when you're looking at Venn diagrams, you always have what's called the universal set, and this is notated with a capital U. And if you want to think about this in terms of, let's say, our statistical study, the universal set is kind of like the population. It's the big picture of whatever it is that we're trying to study or understand. Now, in this case, let's read our set builder notation. So here, again, the first piece, so this is set U. We could also call this the universal set is X such that X is a member of natural numbers and X is between 1 and 20, including 1 and 20. Okay, now we could represent this on a number line if we wanted to, but let's just talk about this. So if this is our universal set, for example, let's say we want to talk about some complementary sets. So let's look at, in this case, set A. We'll notate that with a capital letter. And let's say that set A includes the numbers 2, 4, 6, 8, 10, 12, 14, 16. We're going to go all the way up to 20, and then we will stop there. Okay. Well, looking at this, we could definitely say a couple of things. We could say that A is a subset of U, correct? Because if you look at it, everything that's here in A is also included up here in U, because remember, if we write U out the long way, U would look very similar. It's going to start at 1, and it's just going to be whole numbers, because that's what natural numbers or counting numbers are, and it's going to go all the way up, and it's going to stop at 20. Okay. Now, what we're going to do is we're going to notate the complement. Here we have set A, and we're going to notate its complement. So set A would be notated like this, but the complement of set A would be notated with a capital A and an apostrophe beside it. Now, what is the complement of A? Well, you can translate the complement of A in a couple of different ways. Probably the easiest thing to call it the complement of A. You can also call this everything in set U, or the universal set, that is not A, or not in A. Well, what is that? Let's take a look at it and see what we can come up with. So in this case, the complement of A would be everything in U that is not in A. Well, what all is in U? 1 is in U and not in A. 3 is in U and not in A. and so on. So what we find is that the complement of A is really going to be all odd numbers, starting with 1 and going up to 19. So this is the complement of A. Now, a couple of relationships that we need to note in this situation. First of all, set A intersect the complement of A is always going to be an empty set. There is nothing in common between A and not A. The second relationship we want to note, give us a different color here, is A union, the complement of A, is going to equal the universal set. So going back to my example I just gave, we said that A was even numbers up to 20. There's 2, 4, 6, 8, and continuing. And we said that not A was the odd numbers starting with 1, 3, 5, 7, 9, continue. There is no overlap between these two. There are no numbers in common between these. So that's where you see that A intersect A is going to be an empty set. But if we merge the two of these together, we're just going to end up with, well, it's going to be set U, which was 1 through 20, including 1 and 20, right? And X was a member of natural numbers. Okay? And the last one, if we put these two together and we say the number of elements in set A plus the number of elements in not A, or the complement of A, is going to come out to equal the number of elements in set U, or the universal set. Now let's look at a quick example that might help you guys understand this. Well, if you're following your book, this is example number 3. They want us to find the complement of C. Well, step 1 is we need to know what is U, or the universal set. In this case, it says that the universal set is all positive integers. So U equals Z plus. Well, if we want, we can go ahead and write that out. So U equals X such that X is a member of positive integers. And the next way we would write this out is U equals, and then we put the exact number values. So positives is not going to include 0, and it's going to start at 1, and this is going to be an infinite set. Okay, and C is the set of all even integers. So C equals even integers. So what's that going to be? It's not going to be, let's see, what would it be? If C is all even integers, then not C is going to be, as is everything left in U that is not in C. So this is, C is going to be all of the odd integers. Now the last piece, let's look at this one. C equals X such that X is a member of integers and X is greater than or equal to 2. And in this case, the universal set equals all integers. And they want us to find the complement of C. Well, C is all integers that are greater than or equal to 2. So everything that is greater than or equal to 2 integer-wise is going to be a part of C. So we want to know what is not C. Well, that's going to be what? It's going to be x such that x is less than or equal to 1, and x is a member of integers.